This is Supernovas, presented by Salvetti, Brock, and Jared, where freshman Mrs. Davidson class period 3. 6,000 light years away, a giant dying star is about to implode, creating a giant supernova. The blue supergiant fuses together hydrogen to create helium, but later in its life, the star begins to shrink, causing the helium atoms to change into carbon. The result is a giant buildup of which in turn makes the star grow larger and larger until it is someday ready to create a giant boom. After the supergiant fuses together hydrogen to create helium, the star creates carbon by fusing together helium. After the star fuses helium to carbon, the carbon fuses together to create larger and larger elements, eventually resulting in iron. The iron is a metal that absorbs the energy. This means the energy will be absorbed into the core and the pressure will stop pushing outward. Gravity wins the battle and the star will begin to collapse, making it implode. The star Mennatka, which is 40,000 degrees Kelvin and the brightness of 100,000 suns, can eventually become a red supergiant, for example, the MU Germanium, with a temperature of 3,100 degrees Kelvin and a brightness of 1,000 suns. The pressure in the supergiant begins to get so high that the star collapses in on itself, creating a giant boom that can extend millions of miles through space. The outer layer of the star is ejected in mass explosion. The next stage after supernova has two different possibilities. The remnants of the star will become a nebula, the birthplace of stars, but at the center of that nebula, a neutron star 4 to 8 times as big as the sun, or a black hole 20 times as big as the sun, can be created. A neutron star is gravity that presses material in on itself so tightly that protons and electrons combine to make neutrons. A black hole is hot, dense remains of a star.